For factoring, I'm not going to go through every step. I have different examples and step-by-step instructions on how to solve different problems here using all the methods. The special identities are important. I want you to memorize them, especially the first one, the second one, and the fifth one for this exam. But as we move on with the class, we need to make sure that we memorize each one of those because you should be able to use them. Let's work with the last problem. The first two, please do them and let me know if you have questions. The last one is a little bit strange. I have x to the fourth minus 16y to the fourth, and I don't have any specific identity for this. Nevertheless, I need to realize that x to the fourth can be written as x squared square. So I can split the 4 as square to 2, 2 to the 2. Because as we know, if you have a power to a power, you multiply the exponents and the result is the product. So I have x squared square and 2 to the fourth y to the fourth. I can rewrite this as x squared squared minus 2y to the fourth. But this can be split as 2y to the second to the second. And now I have a difference of squares. I write this as a difference of squares, so I split it down to x squared minus 2y squared and x squared plus 2y squared using the difference of squares. What I want you to see now is that although this cannot be changed, the sum cannot be changed to anything, the left side, that is x squared minus 2y squared, is a difference of squares. And because it's a difference of squares, I can split it further to x minus 2y times x plus 2y. Times x squared plus 4y squared. And this is my final answer. So we want now to graph the parabola that is given in this slide, 4x squared minus 11x minus 3. The first step is to rewrite the coefficients. So we want to make sure what is the a, what is the b, and what is the c. A is equal to 4, b is equal to negative 11, and c is equal to negative 3. In order to graph a parabola, I need 5 components. I need to identify the 5 components of this parabola. And the 5 components are nothing else than the extrema, the y-intercept, the x-intercept, the vertex, and the line of symmetry. First of all, we are going to work with the extrema of our function. When the a is positive, then this means that the parabola opens up. When the a is negative, then this means that the parabola opens down. In this case, a is equal to 4. That is greater than 0. So this means that it opens up. It has a minimum. If it was negative, then it would have a maximum as it will open down. So this is the first important thing that we need to remember. give me a moment here because I have a technical difficulty. The next step that we have to look at is the y-intercept. The y-intercept for a parabola is always the constant. That is, in this case, the -3. Just remember to take the negative sign along with the number. So if you want to write this in point notation, then you have to write 0, -3 because -3 will be the y coordinate. The next step is to calculate the x-intercepts. The x-intercepts for this parabola will be calculated if we set the trinomial equal to 0. So you set f of x equals to 0, and this holds for all the functions. When you want to find x-intercepts, you set it equal to 0. And you, for this specific one, what you need to do is find the roots of that. You can find the roots either using the quadratic formula or by factoring. And this is what I did here. By solving by factoring, right here, I have x minus 3 times 4x plus 1. So the roots of that will be x equals to 3. Either the first factor will be equal to 0, or x equals to -1/4. The second factor will be equal to 0. And this gives me the two x-intercepts. 3, 0 and -1/4, 0. So I have the x-intercepts, the y-intercept, and I know that the parabola that I have right here has a minimum. So the next step is to find the vertex and the line of symmetry. To find the vertex is simple but tedious, because you need to be very careful with your calculations. The vertex is always -b over 2a, f of -b over 2a. That's the point of the vertex, and it's always like that. Okay? To calculate that for our parabola, since b is equal to -11 and a is equal to 4, we are going to get 11 over 4. This is the x-coordinate. Now you are going to take this x-coordinate, 11/8, and you will plug it in to the f. That is 4 times x squared minus 11x minus 3. So you plug in the 11/8 there, and you do the calculations for that. And if you do the calculations for that, then the result that you get is -10, 0.563. So you take the x-coordinate that you found easily by -b over 2a, and you plug it into the function to calculate it for the specific number. As you can see, you may have to deal with fractions. Now, for this presentation, we want to do it really fast, so the answer is -10.563. But if something like this is given, you really need to go through the steps and calculate the fractions and get your final answer. The vertex for this parabola is 11/8, -10.563, The line of symmetry of the parabola, where the parabola is symmetrical around a vertical axis, the vertical axis is going to be x equals to 11/8. So it's going to be always x equals to negative b over 2a. So now I have the vertex, the x-intercepts, the y-intercept, and I know that the parabola opens up. And I'm ready to actually graph the parabola. As you can see right here, we have the x-intercepts, negative 0.25, that is 1/4, negative 1/4, 0, 3, 0, the y-intercept 0, negative 3, and the vertex 1.375, that is nothing else than 11/8, negative 10.563. And I'm ready to graph it. The parabola opens up, and the line of symmetry is equal to x equals to 11/8, or x equals to 1.375. Let's look at some problems together now. These are the problems that we solved together.